Hey guys, I'm Kiori, and today we're going to talk about error bars. So what are error bars? Error bars are graphical measurements that cluster about the true value you are trying to measure. The single data point represents the mean value of data. The error bars are the overall distribution of the data. So what is the purpose of error bars? It is to show the range of uncertainty on a graph, or how accurate your measurements are. Let's take a small example. Suppose you have the measurement of 6 plus or minus 3 meters, with plus or minus 3 being your uncertainty. Let's see how it looks like on an error bar. The single data point is your 6 meters. Since your uncertainty is plus or minus 3, the error bars will show either 9 or 3 meters, plus or minus 3 from 6. Error bars show your range of data on the graph. Types of error bars. There are two types of error bars you will see on a graph. The first is the horizontal error bars. The horizontal error bars show the range of data for your independent variable, which is on your x-axis. The second error bar is the vertical error bars, which show the range of value for data on the dependent variable, or your y-axis. Let's take a simple case of Hooke's law. Here is a data table. In this case, extension is your independent variable, while force is your dependent variable. Let's move it over here. And here is your graph with the points. Let's see how the horizontal error bars will look like on a graph. And let's see how the vertical error bars look on the graph. I will now demonstrate how to create a graph with error bars from scratch. Here is my spreadsheet with the data table. The independent variable is time, while the dependent variable is position. Notice that the uncertainty for time is the same for all measurements, but the uncertainties for position is different for each measurement. Let's start with graphing. Select your x and y values, go to Insert, Scatter, and create a scatter plot. Select all of the dots by clicking on one of these dots. Go to Layout, Error Bars, and More Error Bars options. The Format Error Bars task will come out. Since we're now working on the vertical error bars, we are now working on position. Because position has different uncertainties for each measurement, we have to click Custom and specify value. Here, we can select the uncertainties for each measurement of position for both the positive and negative error values. And then click OK. Your vertical error bars are now formatted, but we still have to fix the horizontal error bars. So now what we have to do is double-click on any one of these horizontal error bars, and then the horizontal error bars task will pop up. Since we are working on the horizontal error bars, we are now working on time, and time has a specific uncertainty for all of its measurements. Thus, we can now use fixed value and then format it to match the one in our data table, which is 0.1. And then we click close. There you go. And now the error bars for both horizontal and vertical are formatted. Let's go back to the presentation. Now that you know how to graph error bars, let's talk about some of the things you should keep in mind. The more original data values range above and below the mean, the wider the error bars and less confident you are of a certain value. To reduce these errors and the error bars, decrease your random and systematic errors. To go further on this topic, we can use the error bars to graph the maximum and minimum gradient. Let me show you in Excel. We are back at the spreadsheet to learn how to graph the maximum and minimum gradients. The points for the maximum and minimum gradient are found by using the endpoints and the information found in our original data table. The highest possible value on our first endpoint and the lowest possible value on our second endpoint are used to create the minimum gradient. In contrast, the lowest possible value on our first endpoint and the highest possible value on our second endpoint are used to create the maximum gradient. Let's start graphing. First, right-click on our graph and press Select Data. Click Add, and now we're able to add in extra information to our graph. Let's start with the maximum gradient. Type in max and select your x values, which are your endpoints. Then select your y values, which are the values you calculated. Press OK. And now let's do the minimum gradient. Press Add once more and repeat. Okay. Now you can see that the points here, red for max and green for minimum, are now all set. But we still have to draw the lines. Click the graph, go to Layout, go to Trend Line, and then press Linear Trend Line. Let's do the line of best fit first, and then our maximum gradient, and then our minimum gradient. And there you go. Using these error bars, we were able to draw the maximum and minimum gradients of our data. Let's go back to the PowerPoint. Thank you. Credits to NC State University and Mr. Baldeep Singh for this presentation.